Let's take a look at the questions on homework number 29. Please note at the bottom here, these two topics only have a requirement of 3 problems. So let's get started with finding the right coefficients of polynomials. So this question asks you to rewrite the polynomial in standard form so that the quadratic has its highest exponent, right, the highest degree first, and then listed in descending order. In this case, this polynomial only has 2 terms, in which case the first one would be positive x squared over 2, and then minus 3x. So our first term would be positive x squared over 2 minus 3x. So this would be our ax squared term, this would be our bx term, and then our c term would be missing, which makes this constant 0. So the value of a, b, and c are the numeric numbers next to the variables, or the constant for the c in this case here. So you'll notice in this first one that the x squared is over the number 2, but the numerator also has a value. So the coefficient for a is 1/2. The coefficient for b is -3, and the constant, which wasn't there, would be 0. Let's take a look at another question. In this one, we don't have a quadratic, but they still ask us to write that in standard form, where the x comes first alphabetically, then y, then the constant. So this polynomial is already written in that form, so we simply have to look at the coefficients. Don't forget, if you don't see a coefficient, doesn't mean it's not there. So in this case, there is a 1 in front of that x. So the coefficient of a would be -1/3. The coefficient of b, which we don't see, is also a -1. And the coefficient for c is +1. Let's try this one more time. This one is not in the right order. So when I rearrange the parts, I'm going to get -1/3 x, I'm going to get -7y, and -2. That allows me to write my coefficients as -1/3, -7, and -2. All right, let's take a look at the next topic, which is the quadratic formula. So identifying the a, b, and c values is important to being able to use the quadratic formula. All right, so first, let's take a look at this question, and then we'll take a look at quadratic formula. So the quadratic formula looks like this. And I know it looks pretty scary, but it is located on your reference sheet, so you don't have to memorize it, but you do have to know how to use it. So in this question that we're being asked to do, we first have to make sure it is in standard form, right? So ax squared plus bx plus c. It must be in this order before you can identify the values for a, b, and c. Because once you know the values for a, b, and c, you're going to plug them into the formula in their correct spots. So let's rearrange this by subtracting 16 from both sides, and that will give us x squared minus 7x minus 17 equals 0. And now I know my values. A is an invisible 1, b is a -7, and c is -17. And this is important because I need to type those correctly into the formula. So I'm going to erase this for a second, and I'm going to write our formula with parentheses instead of letters. And now I have to fill in all of the right numbers in all of the right spaces. So b is -7. Now don't forget, the formula has a minus sign. So if your value has a negative sign, that's going to be 2 in a row. So -7 squared, a is 1, c is -17, and a is 1. Now that's pretty complicated looking, but the good news is you're going to use your calculator here. Now this right here signifies that there are 2 possible solutions. You cannot find them at the same time. You can only type one operation into your calculator, and then you have to do it again by typing the second operation, so you can find both answers. This one asks us to round to the nearest tenth, so when we're done using our calculator, that's what we're going to do. So I'm going to shrink this down a little bit, move it over here. I'm actually going to erase this part because we don't need it anymore. I'm going to open my graphing calculator and we're going to do this together. So let's see here. I'm going to type a giant fraction first. Oops, sorry. I'm going to do that by pressing alpha y equals, get my giant numerator and denominator. Now I'm going to type exactly what I see on my paper so that I don't make any mistakes. So I'm going to type a negative sign, then I'm going to type parentheses, I'm going to type a -7, then I'm going to type parentheses again. Now here's where you have to choose, and it doesn't matter which one you do first, but I always like to do my plus sign first. Then I'm going to enter a square root symbol, and again, type it exactly how you see it. Don't leave off these parentheses because they're important. There's a difference between parentheses -7 squared and just -7 squared. So be careful. All right, there's my entire discriminant type. Now for the bottom, 2 parentheses 1. Now, here's where I will allow you to take a shortcut. You know that 2 times 1 is 2, so if you'd like to just leave it like that, you can. But if you want to be super careful and just type everything exactly, then that's what you would do. All right, we're going to press enter now. We're going to get a really long answer. And they ask us to round to the nearest tenth. So 8.9 is going to be our first answer. So 8.9 is going to be our first answer when rounded to the nearest tenth. Now that was a lot of typing to do, so instead of having to type it all over again, I'm just going to copy and paste it by arrowing up 2 times and pressing enter. And now I have my exact quadratic formula typed, but all I have to do is go back, press my back arrow, and change my plus sign in front of the square root to a subtraction sign. And that's all I have to do, because I already typed it all out correctly. And now my other answer is -1.9. So 8.9 and -1.9. Comma. And that's how I get a space for 2 answers. All right, let's try it one more time. Take a screenshot here. Again, they're asking us to solve to the nearest tenth for this problem. So this one is already in standard form. So this is going to be fast. A is 1, B is -11, and C is -6. Whoops. C is -6. So take my calculator out. Again, type a giant fraction. And I can write it on my paper. That would be helpful. That's actually called showing your work, even though you're using the calculator. So -11 plus or minus -11 squared minus 4 times a times -6 all over 2a. So that's exactly what I'm going to type. Once you're done typing, you're going to want to take a look and see that all of your signs and characters are correct. And you'll see here I made a mistake up there. So I'm going to back up. And I'm going to change this to a parentheses. And now I need a negative sign there. If I start typing negative, look what's going to happen. Oh man, it wrote right over the 1 instead of squishing the negative sign in pushing the 11 over. So if that happens to you, well, all you need to do is press your second delete key. The second delete button has the words INS on top, and that means to insert. So watch my cursor there. See how it's a blinking black box? Once I press second delete, it goes down to just a single line here. And that means that whatever I type, it's going to shove everything over. Instead of overwrite it, it's going to push it over. So now I can type that 1 and get the 11 that I'm looking for. All right, the rest of my characters look good here. -11, and I chose to write my plus sign first, and then I'll copy and paste and go back and do this again. So I'm going to get 11.5, and then copy and paste, and then arrow up and over. And this time I want to overwrite. I don't want to push it over. I actually want to overwrite it. Now make sure you're using a subtraction sign here, not a negative sign. Subtraction sign. So 11.5 and negative 0.5. 11.5, comma, negative 0.5. There we go. All right. Shrink this down. Now let's take a look at our parabola features. So for this next section, you're going to need to know three parts of a parabola. One is the vertex, also known as the turning point, or the min or max. The vertex of a parabola is the point at which the parabola changes direction from either going decreasing to increasing or from increasing to decreasing. And if you were to draw a line through that vertex, a vertical line, you would get something called an axis of symmetry. So if you can define the actual vertex, like for this one here, it would be the point 1, 3. And so since the x-coordinate is 1, the axis of symmetry is the equation x equals 1. So the axis of symmetry can be determined by figuring out the vertex point first. Once you know the vertex point, you can identify the x-coordinate as the axis of symmetry. The vertex is a point. The axis of symmetry is an equation that uses a number from this point. And the y-intercept is also a point. So let's take a look at our first question here. Using the graph, determine the coordinates of the x-intercepts. Now the x-intercepts are different from the y-intercept, and the x-intercepts are also known as your roots, your zeros, or your solutions even. So I see that the graph touches the x-axis at -8 and -6. So -8 and -6 are our two solutions. So it's going to ask us here about our answer type, whether there's 2 points, whether there's 1 point, or whether there's one equation. So for us, it's 2 points. And those 2 points are -8, 0, right, because the x value is -8. And the other one is -6, 0. All right, next question might be something different. Using the graph, determine the coordinates of the vertex of the parabola. Now the vertex is a turning point, so our answer is 1 point. And that 1 point is 1, 4. The next question asks us again to determine the coordinates of the vertex, and the vertex is over here. Again, it is a single point, 1 point, and it is the point -7, 1. This one is also a vertex question, so I'm going to go through quickly to see if I can get to another type of question that you might get. Let's see. Using the graph, determine the coordinates of the y-intercept of the parabola. That would be this single point right here, 1 point, and that 1 point is 0 on the x and -3 on the y. All right, we've reached our limit of 5, but let's see if I can keep going. Here we go. Using the graph, determine the equation of the axis of symmetry. So the axis of symmetry, remember, is not a point. It's one equation. But the equation, which starts with an x and an equal sign, can be determined by figuring out your vertex point. So if our vertex point here is -7, -1, then the x value is our equation. So x equals -7 is our axis of symmetry. All right, I think we've seen all the types from this category now. So let's take a look at graphing parabolas. All right, in order to graph a parabola, you're going to need to find some points. It says graph the equation x squared plus 4x minus 5. You must plot 5 points, including the roots and the vertex. So why don't we open our graphing calculator here. Let's turn it on, and let's enter this equation into our y equals button. Oops. X squared plus 4x minus 5 So first thing I'm going to do before I can look at the points, but why don't we just take a look at the graph so we know what it should look like. Okay, it's an upwards facing parabola. Looks like I have some x-intercepts here at 1, 2, 3, 4, -5 and +1. Right, so -5 and +1. I already know that those are going to be points. I could certainly figure out what this vertex is here, but I'm just going to look at my table and I'm going to graph some really good looking points. So I'm going to do -2, -9. I'm going to do -1, -8. Do 0, -5. Oh, there it is. I could even go up my table. I could have done another one here. -3, -8. But it looks like as soon as you draw 5 points, it's going to plot it for you. And that's because I included the vertex, which I graphed here, and 2 roots. So now I can submit my answer. All right, let's take a look at another one here. Go back to your y equals. We can type over this, plus 14x plus 48. Let's just take a look at how we know we want it to look. Okay, another upwards facing u. I can certainly steal these points right away if I can calculate them. 1, 2, 3, 4, 5, -6 and -8. Oh, it's going to look skinny over here. And now I'm going to look at my table. Let's see what I've got. These are not going to fit, these points, so I got to go up my table here. Let's see, -9, +3, -8, 0, -7, -1, -6, 0, -5, 3. There it goes. Now notice it's going to construct the parabola for you. It's going to draw the arrows as long as you hit these 5 points, including the roots and the vertex. All right, graphing parabolas and stating properties. So here they ask you to graph this parabola. You must plot 5 points again, including the roots and the vertex. And then, using the graph, determine the roots of the equation. So this seems like the same thing we did before. So I'm going to type this equation into my graphing calculator again. I'm going to type, negative x squared this time, plus 8x minus 15. Let's just take a quick peek at how it's going to look. And this time, I have a downward facing parabola. Now I can go ahead and look at the table, but I can pretty clearly see that these roots or zeros or x-intercepts are going to be +3 and +5. Looks like the vertex is going to be right in between here, but let's double check. Second graph, we look at the table. Whoa, those points are definitely not going to fit. So 1, -8. 1, -8 will fit. 2, -3 will fit. 3, 0, which I got. 4, 1. There it is. Okay. Now it's asking us for identifying, use the graph to identify the roots. Now the roots are the x-intercepts, also known as the zeros. So there are 2 of them, so we're going to choose 2 numbers, and we're going to choose 3 and 5. The roots are 3 and 5. All right. You do this again. You go to your y equals button, you graph, you plot, and you identify the 2 roots. Okay. Parabola A values. All right, let's take a look at what the A value of a parabola is telling you. So when you have your standard form quadratic equation, this A value can tell you 2 things. It can tell you whether the graph is going up or down, and it can tell you whether the graph is skinny, like this green one here, we call that narrow, or if it's a bit fatter or wider, like this red one here. So the A value can tell you whether the graph is upwards, like this blue one, or downwards, like this red one, and it is determined by the sign of the A value. If the sign is positive, the graph is up. If the sign is negative, the graph is down. And then the number of the A value, not the sign, but the number of the A value, if it's higher than 1, it's narrow or skinny. And if it's between 0 and 1, or a fraction or decimal value, it's wider. All right, so that's what our a value is talking about when they say parabola a values. So you can drag these graphs and you can really only move them to the left. I've tried to move them to the right, but they don't work so well sometimes. Okay, so the first thing I want to do is identify that I want some graphs that have an a value of -4, -0.25, and positive 0.25. So these two graphs are negative. So you should be able to know that those two parabolas are pointing downwards. So I'll swap these two. This is the only positive a value, so this is the only upwards parabola, so these two have to be the match. Now we have to determine if these are in the right places. The number here, not the sign, but the number here can determine whether you are more narrow or whether you're more wide or fat. So anything higher than 1, this is a 4, is going to be narrow. Anything that's fractional is going to be fatter. So these are properly matched. Let's do another one. Again, look to see if you can identify the signs first. So I have a negative, a positive, and a negative. This is the only positive choice, so it's the only upwards facing graph. So this one is in the right place. Now this is a 1, and this is a 0.25. So this one should be more narrow, and this one should be more wide. These are actually already in the right places to begin with, so I don't need to drag or drop or move any of my multiple choices here. Let's try one more. This one is the only negative number, so it should be the only one that's going downwards. So I'm going to swap these two, and now this one should be more narrow, and this one should be more wide, and these are correctly placed. So again, you're checking for up or down, and you're checking for wide or narrow. So this is the only positive number, so it's the only upwards facing graph. This is downwards, this is more wide, this is more narrow. So I need to swap these two, but in order to move them, this guy went the wrong place. So there we go. Okay, next topic. Plot points in graph, a quadratic given a table. So instead of using your calculator, you're just going to look at these tables here and find points that fit. So you got to plot at least 5, but then you got to draw it yourself. So let's see, I'm going to do -3, 9, -2, 4. I'm going to do -1, 1, 0, 0, 1, 1. 2, 4. You'll notice the symmetry here. I almost don't even need to look at my graph. I'm done plotting points, and now I'm going to try and make a soft curve at the bottom, and then bit by bit I drag it up. All you need to do is make sure that you touch all of the blue points. Whoops, see? I'll do last. Make sure you go through all the blue points and make sure you see that arrow appear. There's an arrow there. See, it's not perfectly curved, but it does fit all of the directions, which is you must go through all blue points and you must have 2 arrows once you're done. All right, let's try this one more time. X squared minus 4. I'm going to look at some of these points. I'm going to start at -3, 5. -3, 5. -2, 0. -1, -3, 0, -4, 1, -3. There's my turning point. I'm starting to see some symmetry. There we go. Done plotting points. And let's see, nice soft curve at the bottom. Then release my mouse. And I'm going to click again, section by section, until I see that arrow appear. So this one was a little farther from the edge of the graph, so I had to draw it a bit longer before I saw those arrows. This one looks like it might be questionable, so let's see. I got it. Okay, now for the next 10 last task, there's only 3 times you have to do this, but this time you have to type it yourself. So you open your calculator, you go to the y equals button, you type in exactly what you see, and it might be written in a different form, but -2, parentheses, x plus 3, parentheses squared, plus 3. Now you'll learn a little bit more later about other ways you can graph this, but let's just go look at the table here. -4, +1, -3, 3, -2, 1, -1, -5. I think I'm going to arrow up here. There we go. -5, -5. So you notice the other points wouldn't fit. They were too high. I definitely see the turning point. I see the shape of the parabola. So I'm going to click Done. And you'll notice the equation had a negative out front. So that makes sense that the parabola is pointing down. So now I'm going to draw my nice soft curve. Well, that kind of looks like a V, but I think they'll give it to me. And then go through all my points until I get arrows. Awesome. So that concludes homework number 29.